In the lecture, we will learn how to apply wind load to the structure. Wind load is also a literal load similar to the seismic load. The wind speed for our structure is 150 miles per hour. We can get this from maps for our structure. Considering the location, the KZT is a topographic factor from ASCE 7-10, chapter 26. The structure on which we will be applying wind load is similar to the structure we are using in previous lectures. Before assigning the wind load to the structure, a very important step is that you need to assign the diaphragm to the structure. For concrete structures, we consider a rigid diaphragm. Now go to load patterns and then apply the wind load. Using ASCE 7-10 and click on add new load. Now go to modify new load. Since we are using exposure from the extent of diagrams and our structure is regular, so we can use this option. If your structure is irregular and consists of a lot of openings and it's simple pergola type of structure or canopy, so you can use exposure from frame and shell objects. But since we are using a reinforced concrete structure, so it is usually having claddings and is enclosed. So that's why we are using exposure from the extent of diaphragms. The wind speed for our structure from the maps was extracted as 150. Using ASCE 7-10 chapter number 26, the exposure category for our structure was extracted as exposure C. You can read the description and it's easy. Or we need to specify the gust factor. The gust factor for a rigid building, since we are using a reinforced concrete structure which is considered as rigid and we have used rigid diaphragms for the structure, so the gust factor can be taken as 0.85. When referring to ASCE 7-10 chapter 26, we need to see the table 26.6-1 for getting the value of directionality factor KD. The KD for main wind force resisting system is 0.85 as we are using a building and main wind force resisting system. Also defined previous from the beginning in ETABS. The eccentric load patterns for the wind. ASCE 7-10 chapter 27 figure 27.4-8. It might be helpful in understanding what this E1 and E2 means: eccentricity in x direction and eccentricity in y direction. Consider the four cases shown: case 1, case 2, case 3, case 4. The case 1 shows that the full design wind pressure acting on the projected area perpendicular to the each principal axis of the structure, considered separately along each principal axis. That is how the most simple case can be defined, but it does not consist of any eccentricity. Case 2 consists of 3/4 of the design wind pressure acting on the projected area perpendicular to the each principal axis of the structure in conjunction with a torsion moment as shown in the figure, considered separately for each principal axis. Case 3. Case 3 includes wind load defined as in case 1 but consists of acting simultaneously at 75% of the specified values. Wind loading as defined in case 2 but considered to act simultaneously at 75% of the specified values. So conservatively, we usually use case 2 when applying the wind load on a high-rise structure. which consists of eccentricity as well as the normal loads in both x and y directions. This is how ETABS consists of wind loads as default. You can check the diaphragm widths taken by ETABS to calculate the eccentricities, and the wind load will be applied to the structure from story 1 all the way to story roof. You can also modify these widths. Exposure width is user defined so that table unlocks and you can specify your values. Wind pressure coefficients. If we use old codes, then wind pressure coefficients have to be specified manually. For example, if we use IPC 2000 or UPC 1997, we have to specify these manually, but ETABS can determine it automatically by using program calculations based on the specified parameters. So it is better to keep it this way. Click on OK and click on OK. That is how we have applied wind load to the structure.